So something huge just happened. On October 22nd, 2025, the world of computing, well, it quietly shifted on its axis. And we're not just talking about a slightly faster chip or some new app. No, this was about a fundamental, brand new capability for science, a breakthrough that could seriously reshape everything from medicine to material science. To really get what just happened, let's start with a pretty simple question. What if we could actually see inside a molecule? And I don't just mean its static shape. I mean, what if we could see how information and energy literally move through it, how all its atoms are interacting in real time? What could you build if you had that kind of sight?
Well, guess what? This is that moment. The entire history of science is really just the history of the tools we've built. The telescope opened up the cosmos for us. The microscope uncovered this entire cellular world. And now, Google has effectively built a quantum scope, a completely new kind of scientific instrument that lets us see the quantum interactions that were, up until now, completely and totally invisible.
And this, right here, is the crucial point. For years, for so long, quantum computers have basically been studying themselves. It was science on quantum computers. But with this breakthrough, we've crossed this incredible threshold. We are now officially doing science with quantum computers, using them as a tool to finally probe nature itself.
So here it is, the big headline: verifiable quantum advantage. That means a quantum computer solved a genuinely useful scientific problem, and it did it thousands of times faster than the best supercomputer on Earth. And the most critical part is that we can actually check its work and know the answer is correct. That's the game changer.
So, you're probably wondering, how on earth did they actually do it? Well, the algorithm is called quantum echoes, and the idea behind it is just brilliant. Think about how a submarine uses sonar, or how a bat uses echolocation to map out its surroundings. They send out a pulse, and then they just listen for the echo. Google basically did the quantum version of that exact same idea. You know what's so cool about this is how simple it sounds when you break it down. First, they run a calculation forward on their quantum chip, which is called Willow. Then, they do something really clever. They introduce this tiny disturbance, like dropping a single pebble into a pond, by just poking one qubit. After that, they run the entire calculation in reverse. Finally, those forward and backward signals interfere with each other, and that creates a unique echo pattern that they can measure. And that echo, it's not just random noise, not at all. It's a super precise measurement of something called an out-of-time order correlator, or OTOC for short. Just think of it as a way to map how that tiny initial poke spreads and scrambles information throughout the whole quantum system. The reason this has literally never been done before is that these signals are incredibly faint. We're talking like trying to hear a single whisper in the middle of a packed stadium. Okay, so right about now you might be thinking, hang on, haven't I heard this story before? And you're right to think that. Back in 2019, Google claimed quantum supremacy, but what they've just done, it's fundamentally different. And believe me, that distinction is everything. All right, let's break this down. The supremacy claim back in 2019 was based on an artificial problem, one that was designed specifically to be hard for classical computers. It was like building a car that could go 300 miles per hour, but only on a special, perfectly straight test track. Super impressive, right? But not really useful in the real world. This new advantage solves a useful problem, and this is the key. Its answer can be verified against physical experiments. It's like taking that 300-mile-per-hour car and proving it can navigate real-world roads, curves, and this quote just nails it. This isn't just about we think it's faster. It's about we know it's right. See, that's the key. That verifiability, that's what builds trust. It's what separates a cool one-off stunt from a repeatable, scalable scientific instrument. It's the moment we can stop just trusting the quantum computer and start actually using it to discover things we don't already know. Okay, so we've got this new tool, but how did it actually do in its first real-world test? Well, to prove this thing wasn't just a lab curiosity, Google teamed up with researchers at UC Berkeley to tackle a real-world chemistry problem. They put their quantum computer in a head-to-head challenge, a showdown really, against NMR spectroscopy, which is the absolute gold standard for analyzing molecular structures. And the quantum computer's predictions? They didn't just come close. They matched the physical NMR results perfectly. But here's the kicker. It then went further. It revealed information about the molecule that NMR simply couldn't see, acting like a longer molecular ruler to measure interactions that were previously hidden. And get this. It did this task 13,000 times faster than it could be simulated on one of the most powerful classical supercomputers on the planet.
I mean, that isn't just an improvement. That is a completely different league. Okay, so why should you care about this? Why does any of this matter so much? Well, it all comes down to one simple fact. A molecule's shape determines what it does. In drug discovery, you're trying to design a key that fits a specific lock. Right now, that's a painfully slow, expensive process of just trial and error. With this tool, you can basically design the perfect key on a computer before you even step foot in a lab. This could absolutely revolutionize how we create new medicines, better batteries, and all kinds of new materials. So this incredible breakthrough, it's not the end of the story, not even close. It's really the beginning of a brand new chapter. So the big question is, where do we go from here? Just look at this timeline. The pace of progress it's accelerating like crazy. Just last year, the Willow chip solved a massive error correction problem. Now it's demonstrated verifiable advantage. The next huge milestone is creating something called a logical qubit. You can think of it as a nearly perfect quantum bit, built by using several less perfect physical ones that all work together to cancel out each other's errors. This is the key to building quantum computers that are truly fault-tolerant.
And here's the bottom line. Google is now predicting widespread, real-world applications within just 5 years. And that's not just them being optimistic. The reason they can say that is because the fundamental science problem has been solved. Now, it's an incredibly hard engineering challenge, for sure, but it is no longer a fundamental science problem. The path forward is clear. So when you boil it all down, this is about so much more than just faster computers. Think about it. We built telescopes to see the stars, and we built microscopes to see cells, and now we've built a quantum scope to see the very inner workings of matter itself. We've literally just been given a new sense to perceive reality. And that leaves us with one incredible question. What are we going to discover with it next?